Educational Communications and this station present Environmental Directions with Nancy Pearlman. On this series, we explore the effects of human influence on the Earth's ecosystems and discuss solutions to environmental problems which affect the quality of life on this planet. Environmental Directions gives you the kind of information you need to help you participate in decisions impacting your community, the nation, and the world. Now, here's your host, Nancy Pearlman.
Hello. We're going to be talking about water as a renewable energy source with my guest, Gregg Semler. He is CEO and founder of In-Pipe Energy. He is a member of the American Water Works Association, also the Association of California Water Agencies, and the Water Efficiency Alliance. Welcome. It's a pleasure to have you with us.
Thanks, Nancy. Great to be here.
Your company is developing a product called Hydro Excess that converts running water to renewable energy. How does that work?
Yeah, thanks, Nancy. That's a great question. So we have developed a product line that integrates with existing pressurized water pipeline infrastructure to produce a new source of renewable energy. We call our product the Hydro Excess. And the Hydro Excess basically combines micro hydro technology, a turbine, with controls technology in a bypass that interconnects with a pipeline and allows water utilities to manage the flow of the water and the control pressure, but instead of wasting the pressure as is done today, it produces a new source of renewable energy.
Are you saying that the water in our current system where we get the water and turn on our faucets could at some point before it comes to our homes or offices or schools actually be turned into energy as well?
Exactly. That's exactly what we're trying to do. We're trying to develop a system that makes it easy for people who manage large water infrastructure to also be able to provide a new source of renewable energy.
But how does this work when we have an infrastructure in most of the United States that's old, ancient, dilapidated, falling apart? The pipes just aren't doing the job.
Absolutely. Water and electric infrastructure is old and aging and decrepit, just like you say. But we need to invest in it. We need to build it up, and we need to make sure that it's more resilient. I mean, one of my biggest concerns is with the electric grid being as fragile as it is, that there are times when water won't be available. And you could see in Houston a few months ago, that very same thing happened. I think it also happened in Atlanta, where the grid went down and people were without water for days. We don't want that to happen.
If you're using the water to create energy, how much energy can be created so that we can get rid of coal-fired power plants, we can get rid of nuclear power plants, which are so dangerous, we can get rid of other kinds of energy sources that are pretty polluting?
Absolutely. From our perspective, it's really unlimited, the amount of energy that you could produce through water pipelines. But today, we estimate that we could generate about 12 gigawatts of potential energy. That's enough electricity for about 12.6 million U.S. homes and offset about 1.2 billion tons of carbon.
Don't you have to build a new infrastructure to take that energy from the water source and put it into the electrical grid?
Not at all. It all exists. Like today, water is flowing underneath the streets in our cities, and we've developed a system that can tap into those pipelines and generate a new source of renewable energy. It connects to the grid just like solar energy does, and so it meets the requirements that are acceptable to electric utilities. What's really interesting is that water and electricity follow the same pathways. They're both built on meeting the demand of a local community. And so water and energy are really closely linked from an infrastructure perspective as well. So with our product in place, it can harvest the energy in the flow of the water on the pipelines and then go directly onto the grid, just like a solar energy system would at the top of your house.
Environmentalists have always been advocating renewable energy sources, but the problem, even with renewable energy, is that sometimes they use precious metals like solar panels. Sometimes they destroy ecosystems like hydroelectric power plants and dams. So with your system, What kind of materials are used, and are they being obtained in a sustainable manner?
What attracted me initially to this opportunity was that this is energy that basically comes from a waste stream, which we call pressure or flow. So it's happening all the time, and when we're not turning it into energy, it's just flowing, and it has no environmental impact. There is no habitat, there's no fish, there's no plants that are being impacted by this energy. And so the thing that really excited me was this is energy, baseload, dispatchable power that has no environmental impact. And all the other sources of energy that I've been able to think about all have environmental issues that environmentalists don't like, and that makes permitting very, very difficult. In our case, that's not the case. Permitting is very easy and acceptable, and there is a pathway to getting all the interconnection requirements and permits in place. Now, you asked the question about the materials. So the materials that we're using are mostly off-the-shelf hardware integrated with a software-based control system so that it can work efficiently and with a minimum amount of maintenance, co-located with the existing structures. We do use steel, which uses a lot of energy in its production, but we're not using any exotic materials or anything that really have an impact. In fact, our efficiency in terms of carbon, what we call return on carbon, is lower than any other source of energy.
You are proposing this here in the United States. Are there any other countries already doing it or planning to do it? Or what is your competition here in the U.S. and elsewhere?
We're the only company that I know of in the world that is working on a full product line, a turnkey solution for large water operators, whether they work in industrial facilities or factories, or whether they work in agricultural facilities or cities. We work with the largest water users in the world. And we are doing projects in countries like Australia and Thailand and the UK and so forth. In fact, we're inundated with interest outside the United States, but we are the only folks so far that I've been able to identify that have a full product line to really support the requirements of the water and electrical utility industry.
We talked many years ago about these ideas when you were just getting going, and many years have passed. How long does it take to really develop it and get it accepted and utilized?
That's a good question. It's a very challenging environment. Water is very regulated. The electric utility industry is very regulated. It takes a long time for new systems and products to be adopted. The good news for us is that we have a system up and running that's been operating for over 2.5 years without any incident. The operators love it, the engineers love it, the community loves it, and we're working with them on several more projects. We're working on another project where we're working on second and third projects. So in all the cases of places where we have located our product so far, we are talking to the cities about doing more projects.
Who is funding this? Because I know that you want some government money from the Inflation Reduction Act, but shouldn't private investors really take the load, not the taxpayer?
So the company was started by me and funded initially by me and a number of wonderful angel investors. And then we did what's known as a Series A, our first institutional round of investment back in September of 2021. With a venture fund called Full Cycle, which is a global climate-focused investment fund. And so they're super excited about us. In fact, they've committed hundreds of millions of dollars to us to build out water infrastructure. So now we can go to cities across the country and basically say, hey, we have $50 million, we have $100 million. We'd like to make your city more efficient, more sustainable, and more resilient, and we'll take all the risk. We'll invest the money and pay for that. All we want in exchange is for you to purchase the energy. When we create energy, we want you to purchase it.
We've been talking primarily about agencies in California, but what is the federal involvement?
So the federal position on climate change is very clear. They have allocated trillions of dollars to battle climate change and to rebuild energy and water infrastructure, to decarbonize, and to really target underserved communities. If you're a water utility or a factory or an agricultural facility, a mining company, there's never been more money available to rebuild water and energy infrastructure. And so we worked really closely to ensure that the hydro excess would be included in the tax incentives that were recently enacted in a program called the Inflation Reduction Act. So the IRA basically subsidizes those investments, and up to 70% of a project for a tax-exempt community can take advantage of that.
You're a member of associations of governmental and business groups, individuals, agencies working on water issues such as the American Water Works Association, the Association of California Water Agencies, but there's a new group, the Water Efficiency Alliance. How do they make water efficient? What are they doing?
That association is really focused on conservation of water, saving water.
In addition to conserving water, should we not also be conserving energy even if we use renewable energy?
Absolutely. We should do whatever we can to minimize our energy and water footprint.
How do you track your carbon footprint? Because I know it's important for us to reduce our energy use, to reduce water loss, so that we have a positive impact on the climate change problem, and we need to reduce carbon emissions.
So water is very energy intensive. It takes a lot of energy to deliver water, and it takes a lot of water to deliver energy. So that's very carbon intensive. We want to improve how pressure management happens so that we can reduce the carbon intensity, the carbon emissions that are being spewed out through the delivery of water in cities.
There are hundreds of cities in California and thousands across the country. I don't know how many water agencies there actually are in California. How do you decide who to approach? The big cities, the little cities, the large agencies, the small ones?
It's very challenging because nobody really wants to be first. They want to see who else is doing it. So the challenge is that it's a very fragmented industry. But the good news is that once you have a system up and running, then you can have people come and visit. So we just installed a system in Oakland, in the Bay Area, with a very iconic water utility. We've already had several water utilities come and visit.
It's great that you are still pursuing this idea. I look forward to visiting and seeing how it actually works. And I'm sure that people can go to your website, see some pictures.
Absolutely. It's inpipeenergy.com, all one word.
Thank you so very much for giving us an update on your project, and thank you for being my guest.
Thank you so much. It's great to talk again.
I have been speaking with Gregg Semler, who is the CEO and founder of InPipe Energy. I'm Nancy Pearlman. Thank you very much for joining us, and do tune in again next week.
If you would like free information about these environmental issues, go to www.ecoprojects.org or call 310-559-9160. Environmental Directions with your host, Nancy Pearlman, is a community affairs program of the nonprofit organization Educational Communications and this station.